Okay, we're now going back to use our skills of finding area to finding the surface area of any shape. Now the surface area means how much cardboard is it made out of and things like that. So we have what we call a closed solid, and a closed solid would be like a shoebox with a lid on it. And so I'll draw a shoebox here. Here's a box, and it means it's totally enclosed and it's got the lid on it. And it would be like how much cardboard is used to make the box. We could have a cylindrical, might be a lolly tin, and it's closed if it's got the bottom and the top on it. Now an open solid is obviously not going to have quite so much cardboard or tin or whatever it's made out of. It's going to have the lid off, so you could have the cuboid shape like the shoebox without the lid, so it's got all the round but it hasn't got the lid on it. Or you could have a cylinder without the top or the bottom, and of course when it's like that it's called a pipe. Okay, so we're going to learn how to find the surface area of these different shapes, and always take note whether it's closed or open. Okay, we'll start with a prism, and it's like a shoebox. Calculate the areas of the front and back faces. So here if you've got to find the area of each face and then add them together. So when you're setting it out, put area of front and back equals, always state what you're doing. So here we've got a face, that one facing us is 8 by 10, but we've got two of them, 2 by 8 by 10, because the other one's over here facing it. They're both the same shape. So we've got two of those, so you work out what that is. You could do it all at once on your calculator, but I'm going to work them out separately. 160 centimetres squared. Now we're going to do the top and the bottom. So the area of the top and the bottom. Now if it was open, you'd only do the bottom, not the top. And now what have we got here? We've got a 10. Now that 6 is also the same here, so it's a 10 by 6, and we've got two of them, 2 by 10 by 6. And remember we're finding areas, so it's in centimetres squared, 120 centimetres squared. And now we've got the two ends, and what are the areas of those? Area of the ends equals 2 by 6 by, and that 8 is also here, it's the height of the box, so 2 by 6 by 8, and work that out, 96 centimetres squared. And now you're going to add all the faces together, and you should get 376 centimetres squared. And we put surface area equals, SA stands for surface area. Okay, so let's try the one underneath. Calculate the area of cardboard used to make the box. Okay, set it out, like I said, area of front and back equals, so we've got 2 by 12 by 5. Work out what that is, 120 centimetres squared. Area of top and bottom, we've got two of them, and we're assuming this is a closed box. It doesn't actually say, but we'll assume it's got the lid. 2 by 12 by 8. If it didn't, we'd only have one of these. 192 centimetres squared. And the area of the ends, 2 by 5 by 8. So we've got all our ends and tops and things. Comes to 80 centimetres squared. We add them up and get 392 centimetres squared for our surface area. or area of cardboard used to make the box. Okay, go into the booklet and do the first 4 questions on page 30 before you go on to the cylinder. Okay, now the cylinder's a little bit different in that we have to find a curved surface area. Now the surface area of a closed-in cylinder, this is a closed cylinder, you have the curved area around here, and you have the top and the bottom. Now the top and bottom are just circles, so we know we've got 2 lots of pi r squared. That's our circle. Circle ends, top and bottom, got 2 of them. This part is the curved surface part. Now the reason why it's 2 pi rh, think of your toilet roll, that cardboard bit in the middle, and if you cut it down the middle and opened it out, it would form a rectangle. Now this circumference of this circle up here, the circumference around here, actually goes down to form that length of the rectangle. So the formula for the circumference is pi d, or 2 pi r. We'll use 2 pi r here. So we know the length of that is 2 pi r. Now the height is just the height of the roll. So that's where we get the 2 pi rh. It's the area of a rectangle. Okay, so let's go ahead and find it. And so we just plug in our numbers. We've got 2 times pi times the radius is 5 times 5 squared plus 2 times pi times 5 times h. Surface area equals, you can put all in your calculator at once, and you should get 502.7 centimetres squared, because you're finding the area. It's not cubed. Now, if it's an open cylinder, or say it's an open pipe, like a toilet roll with no ends on it, only use the 2 pi rh part, not the top and the bottom, when you're finding the surface area. Okay, we'll move this down, and here's one for you to try. Calculate the surface area of cardboard used to make a toilet roll. Now we'll just assume it's 2 centimetres in radius and is 8 centimetres high. So let's have a look and see. Now we're not going to use the, it's an open cylinder. And so the surface area is just going to be 2 pi rh. So put your numbers in, 2 times pi times 2 times 8, and use your calculator, and you should get 100 centimetres squared. Okay, so be careful whether it's got is an open or closed shape, and just find the areas. Okay, you've got some to find on your booklet on page 31 and 32. Now, don't only worry about the cuboids and the cylinders. Don't worry about any other shape. So, but if you want an extension, do the other shaped solids. Great.